Okay, this is Advanced Math Set 84, Factorable Expressions and Sketching Sinusoids. Okay, so the first thing I would do is recommend that you just take a look at your book and look at these expressions that are listed there and the way that they are factored. I'm not going to go over every single one just because I think if you just look through them, you can kind of see the patterns. I am going to make a note of two of them, and that would be this one and this one. So let's just talk about those two really quick. When you have a similar expression that is not using signs, it would look like this, and the way that we would factor that would be 1 minus x and 1 minus x. So that's where the 1 minus sine squared x and 1 minus sine squared x comes from. For the other one, think back to what it looks like when you have an x cubed minus y cubed, and you may or may not remember, but it looks like this. So it's just following that pattern. Okay, so examples. Show that sine x minus sine x cosine squared x equals sine cubed x. So this is one of those where you just kind of have to manipulate to show that it's true. So the first thing that we can do is pull out the sine x out of the first two terms, and we get sine x outside of 1 minus cosine squared x. And then 1 minus cosine squared x should look familiar to you because it is equal to sine squared x. And then when we multiply those out, we get sine cubed x, which looks just like the beginning. Let's do another example. Okay, so this one's a long one. I would look at the top of the denominator first, secant to the fourth x minus tangent to the fourth x, and factor that out. So you get secant squared x plus tangent squared x times secant squared x minus tangent squared x. And then you can just write out the rest of it. And you may notice now that you can cancel. So go ahead and cancel those two expressions, and then you're going to be left with secant squared x minus tangent squared x plus tangent squared x. You have two terms that you can cancel here because negative tangent squared x plus tangent squared x goes away. So we're left with secant squared x, which is what we were looking for in the first place, and so we have shown it. Okay, another example. Show that cosecant squared x minus 1 over tangent x is equal to cotangent cubed x. So this is an example where they show that even if you do factor it, sometimes it doesn't work out. So you could factor it and say that cosecant squared x minus 1 is the same as cosecant x plus 1 times cosecant x minus 1. And then we put that over tangent, and there's not really anywhere to go from here. So we're kind of stuck. So we'll stop doing it that way and let's try a different way. Okay, so hopefully you remember that cosecant squared x minus 1 is equal to cotangent squared x. If you don't remember that, you can flip back a couple pages in your lesson. I can't remember, it's a few lessons back where it lists all those different identities, and that's one of them. So we can take cosecant squared x minus 1 and substitute in cotangent squared x, which is a lot more helpful. Okay, and then we'll take tangent, get it out of the denominator and turn it into cotangent. Multiply those out. You get cotangent cubed x, which is what we wanted in the first place. Okay, so now we're on to the second part of the lesson, which is sketching sinusoids. So hopefully you remember that sine and cosine equations are of this form. We're just going to review it really quick. A is the center line of your graph, That's going from top to bottom, not from left to right. So from top to bottom, A is the center line. It tells you where the center is. B is going to tell you the amplitude. It's going to tell you how tall, how far up and how far down that your graph goes. Then when we look at C, C has to do with your period. So C is 360 degrees divided by the period. So whatever number that is going to be, when you divide it by when you do 360 divided by that, it will give you C. Or it's also 2 pi divided by the period. Okay, D is the important part today, and D is your phase angle, and that's what we're going to spend some time with today. The phase angle is always going to be subtracted from theta, and so if it looks like it's a negative, it's actually positive. If it says plus D, then it's going to be a negative angle. So a little bit more about the phase angle when you're graphing sinusoids. First of all, if you're graphing a sine function, the phase angle tells you where your curve is going to cross, and then you add or subtract half of the period to get the other crossing points. When we talk about cosine tells us the maximum of the curve, and then you add or subtract the half period to get your other maximums and minimums. So it gives you your other extremes. So sine is for crossing and cosine is for maximum and minimums. Okay, so here's the steps of graphing a sinusoid. First, you're going to sketch the curve. Just sketch a curve that looks like this. Secondly, you're going to add your vertical scale. Third, you're going to find the phase angle and label it. The phase angle for sine is going to be here. For cosine, it's going to be here. Fourth, you're going to find half of the period and then label the other points. Once you find half of the period and then you add it to what your phase angle was back here at the beginning, then you're going to add it to your other points. And your other points are going to be here for sine, and they're going to be here if it's cosine. And then lastly, you're going to find and label the y-axis, which will make more sense when we're doing the problem. So you'll find and label the y-axis. Okay. So here's your first problem. Sketch -10 plus 2 sine 3 x minus 45. So the very first thing that we're going to do is we just draw the sinusoid graph and then put the axis in there. The first thing we're going to look at is that -10. That tells us that's the midpoint of our graph. It goes right there. Then we'll look at the 2. That tells us we're going to add and subtract 2 from -10. So we get -8 and -12. Then we'll look at that 45 degrees. Since it's x minus 45, 45 is our phase angle. I think that's what it was. I can't remember the name of it. Anyway, that's the one that goes right here. So 45 degrees goes here. It's a sine, so we know it's where it crosses. The next thing we're going to look at is that 3. So we know we have to figure out what our period is. And remember, the period is 360 divided by this number. In this case, it's 3. So the period is 120. So that means if we were to go one full rotation, that is going to be 120 degrees. So the difference between 45 and this point is 45 degrees, or is 120 degrees, but that's not what we're looking for. We're actually going to find this point here, and so in order to do that, we are going to do half of the period, which is 60 degrees. When we add 60 and 45, we get 105. And then go ahead and add 60 and subtract 60 to get all of your other points. Okay, the last step is we need to find the y-axis. So you can see between 15 and 45, you could divide it into 4 equal pieces, and 0 is going to be on that first of the 4 pieces, so it's about 1/4 of the way between 15 and 45, negative 15 and 45, and that is your y-axis. So that's your graph. Let's do another one. Okay, this time we're dealing with cosine, and we're also dealing with radians. So let's go ahead and start. We draw our graph. We're going to take that -2, then we'll take that 4, add and subtract it to get our amplitude. Then we're going to, we know it's a cosine graph, so that means we're dealing with maximums and minimums. So it's going to be here or any of the other maximums. Then we're going to look at that 2 pi over 3, and we know that that's where that goes. And since it's plus 2 pi over 3, we are going to put a negative 2 pi over 3. Now we need to figure out how to label the other points. So we're going to use that 2 to find the period. So our period is going to, and because we're dealing with radians, it's going to be 2 pi divided by 2. So in other words, our period is pi. And then if we want to find the next extreme point, which is a minimum, then we're going to do the period divided by 2, which is pi over 2. In this case, I think it's easier just to add pi to begin with, so that's what we're going to do. So if we add pi to go one whole period, it's going to be going like this. So our next point is going to be right here. And so if we add 3 pi over 3, we're going to get pi over 3. And then if we add 3 pi over 3 again, we'll get 4 pi over 3. Now, let's add pi over 2 so we can get these minimum points. And negative 2 pi over 3 plus pi over 2. When you do that math, you get negative pi over 6. And then you can figure out the others. 5 pi over 6. The last thing that we're going to do is try to figure out where 0 is. So 0 is in between negative pi over 6 and pi over 3. We can divide that into thirds. There are actually between negative pi over 6 and pi over 3, there are 3 pieces. And we're going to put the y-axis about 1/3 of the way. And that's it.